What if a conversation could change your mind about yourself and about the world? What if a conversation could one day lead to a change in government policy? I'm Dr. Mark Halloran, and you're listening to Deep Trouble.
Hi and welcome. We are back in the studios of 94.9 Main FM. I'm Steve Proposh, editor of Trouble magazine.
And I'm Dr. Mark Halloran.
And you are in deep trouble. So here we are, Mark, back in the studios of Main FM to record another Deep Trouble. Let's talk about the interview this week.
Sure.
It's Tim Errington.
Yes.
From the Centre of Open Science.
Yeah, so Tim Errington is the metadata science manager of the Centre for Open Science, which is a centre which is funded by the John and Laura Arnold Foundation. John Arnold is an American billionaire and hedge fund manager who was interested in philanthropy and wanted to find the most effective place that he could send his money to in terms of scientific research. And what he found was that there was a lack of reproducibility within science, a failure at the phase 2 level, clinical trials and human trials. So he wanted to find out what was going on, and so that centre was established.
Right. So this is about reproducibility of experiments. We covered this a little bit with Jennifer Byrne. Can you tell us the differences in this interview?
So I guess the main difference would be in the Jennifer Byrne interview, Jennifer's really talking about cases of fraud within Chinese laboratories and the issues related to that, whereas the interview with Tim Errington is about a general concern around what's happening within the culture of science, which includes science throughout the world and across disciplines as well. The contention of Tim and the Centre for Open Science is that science is in a state of crisis to some extent, and the crisis is one of reproducibility. So the philosopher Thomas Kuhn said that reproducibility was the natural state of normal science, which is reproducibility is where if I conduct a study and I release the results and they're significant, another scientist can come along and take my methodology and my statistical methods and reproduce my study to see whether they can find the same results. And because of lots of political and economic funding decisions that currently occur, reproducibility doesn't occur in science as often as it should.
So this is about the pressure to publish as well, isn't it? And be seen in those major journals. In order to have funding continue, you need significant results, and no result doesn't guarantee any further funding. It's that sort of pressure that's on science these days?
Yeah, you can't get by with null results. You can't start a career with null results. It's the pressure to get into nature, to get into science, to get into Cell. And we're talking about some of the ramifications of that, which I might add, if you listen to the interview, seem dire.
Okay, well, looking forward to this one once again. Another episode of Deep Trouble. Let's get into it.
So could you start off by telling me a little bit about what the Centre for Open Science is and what the Centre hopes to achieve?
So the Center for Open Science, we're a nonprofit organization that's committed to increasing reproducibility, openness, and integrity of scientific research. And that's agnostic to discipline. And so we do this through three main activities. We're foremost a technology company. We are providing free open source technology for researchers to basically make it easier for them to be able to make more of their research open. We do some community work that is to work with various incentive drivers within the scientific enterprise, so journals, funders, institutions, to try to align the incentives to basically encourage researchers and reward researchers for being more open and rigorous in their research. the part that I lead is Metascience, so research on research. So essentially trying to take a step back and say, what does our current research enterprise look like? And if there's any type of incentive that we want to use to change, how does that look? Do we actually get the outcome that we want? And so in the end, what we're hoping to achieve by all of this is to work in concert to essentially encourage, more transparency, more openness in the research process that allows more scrutiny, more rigorous design, trying to actually pull in some of the aspects that occur in clinical research, such as registrations, and bring that into preclinical designs to essentially increase that rigor. That we think overall actually leads to an increase in efficiency. Right? This is really about putting the best foot forward and being resourceful and conscious of how we're using our resources, so that way we can achieve any given research area as quickly and as efficiently as possible.
The thing that I was interested in, because my background, I did an undergraduate and an honours degree in psychology, but then I moved on to doing a PhD in biochemistry and molecular biology. So I guess there's two arms of the research that are interesting to me. The first one was the first Reproducibility Project was in relation to psychological research. What your centre found was the original studies, which had been taken from top-tier journals, that 97% of the original studies had significant results, and 36% of the replications had significant results. So there's a massive discrepancy between the two findings.
Yeah, and that's you picked up on one of the ways that was measured, right? You picked up on statistical significance, which is one of many ways that one can kind of try to wrap their heads around, like, what does it mean to get the same result? But even with the other measures, right, like the size of the effects, the effect size, even subjective assessment, right, asking, the people who did the replications, do you think this replicated? All of those were below 50%, right? They kind of sat in this, 35 to 40%-ish range, which, none of them are perfect in terms of like, what constitutes a success or not. But you're right that there's room for improvement is probably the best way to put that. And there's many reasons why those could be off, right? Part of it is the way that we design our experiments. Psychology is no different than cancer biology and any other field, which is sample size is a big problem. So if you're doing a study with a very small sample size, there's a good chance that you're probably going to find some statistically significant effect. But if somebody comes back through, they're not going to find the same thing, especially if they increase their sample size accordingly and appropriately. And so I think that was a big part of it, which was just the design, just the way that those experiments were being designed. Another big one that you can't really point the finger at in terms of saying, oh, this did or didn't, is or is not a reason, is it's very common in many fields, especially that ones that are driven by statistical significance as a way to get things published, is to p-hack, right? To essentially kind of analyze the data multiple ways until you finally find one way that pops out that less than 0.05 statistical significant result.
Data mining.
Exactly, data mining. Yeah, and that's fine if you're exploring. That's fine if you're trying to shift and look for some pattern that you then want to test. But it doesn't work when you actually try to sit there and say, oh, look, this is what I found. I think this is what's going on. So when those replications were done, everything was defined beforehand what the test was going to be, right? So before they even did the experiment, they said, this is what we're planning on doing. This is how we're going to analyze our data. This is how many participants we're going to enroll in our survey, for instance. And that's not traditionally how psychological research is done. Really, outside of clinical research, nobody really does that. And I think that changes things a lot too, right? Because now instead of saying, oh, I'm going to dig through the data, hunting for something that is statistically significant, I'm instead being more confirmatory in my research, saying, well, if I think there's actually an effect there, it should exist, right? I should be able to test and see if it exists. And I think the Psychology Project was a good example of, what happens when you do that, right? You don't see as many significant results. And, whether those are real or not, you can always go into further research and say, well, maybe the size of the effect is smaller. You need more people to see the effect. Either way, I think it's a really good awakening in terms of the way the research should be done, which is, instead of sitting there data mining, hunting for something that's statistically significant just so you can get it published, it's probably a lot better to sit there and define up front what you're planning to do and making sure you're being as rigorous as you can in that design and analysis strategy.
We probably should explain to people the importance of reproducibility within scientific research.
Actually, the beauty of science is, you don't just believe somebody, you can actually go and you should be able to recreate the result, or at least dig through it and fully understand how they arrived at that result. And that's kind of all of what reproducibility is wrapped into, right? Is that essentially confirmation is not quite the right word. It's more of that ability to go through and for oneself, see if you can get a similar result, or at least follow through the entire process in a way that's fully understandable.
So basically, I think the idea is that when someone produces a piece of work that finds something that's important or significant, I don't believe them just because they're an expert. I then test their theory and test their results myself.
Absolutely right. And that's the beauty of science, right? Is it's not about who that person is, where they are, where that information was published, where that paper was published. It's exactly what you said, is that anybody should be able to go back and understand it and test it again themselves. And there's multiple degrees of that, but in terms of just the analysis or redoing the whole experiment again. But yeah, that type of information, that type of full transparency and that ability to have a result that can be repeated over and over again is a hallmark of science. One thing I think that's important that for whatever reason we've kind of forgotten, take psychology, take what we were just talking about, and somebody does some experiment within a United States population, and somebody else tries to replicate it in Australia, and the population is not exactly the same, but there's no reason to think that you wouldn't obtain the exact same result, whatever that finding is. If it turns out that you can't, and both results are completely valid, right? There's no reason not to. They're both well done. Then it actually tells you the limitations of that outcome. And I think that's actually really important for us to understand, right? Is that's kind of what we're trying to do in science, is we're not trying to prove something. We're actually constantly trying to look to disprove something.
I mean, that is slightly a separate issue, isn't it? I mean, that shows scientific rigour. That is showing that something is not generalisable from one population, if that's the explanation that the researcher gives.
Right. And I think that's part of it, because it's right now it's pretty commonplace because we're trying to sell our results, which is kind of a funny way to think about it, right? We're trying to sell our results to get them published so we can get grants, so we can get jobs. And we're overgeneralizing everything. And we do that because it's more exciting, right? Nobody wants to hear about some result that only, holds weight in a small town in Wisconsin. They want to know about, this is the next big thing. And I think the danger in that is, well, one, it's nice because it gets attention, but the danger is if you've never tested that, you just completely overstated something. You never put the limitations of what that research has, which all research has limitations. So I think part of this entire, the psychology project, a lot of this discussion that's going around this is basically remembering to put those constraints, because it's important not to overgeneralize. So,
I mean, there are 100 papers that were published in 2008 in 3 high-ranking psych journals. The Reproducibility Project was only able to reproduce somewhere between a third and a half of the original findings. How did the researchers respond to that?
The original researchers? I think probably a good sum in terms of like what that approach was looking at Dan Gilbert's response. Dan Gilbert is a psychology researcher at Harvard, who wrote a critique to the way that the psychology project was done and the way that the results were presented. And I think that's a good one, which is there's a bit of denial. There is no problem. There's a bit of looking at it. Actually, the reason I bring up the generalizability is because that was part of that critique, was saying, oh, well, you overextended the results. That was done in Germany. It should not have been, repeated in the United States, or if it was, it wasn't done the right way. And again, it's pretty easy to do that after the fact, right?
The results aren't that powerful, really, then, are they?
That's right. I think all scientists, we do this. All humans do this. We look for patterns. And I think even if somebody says, is there no reason not to think this is going to, replicate, if the original author says, yep, I think that's a good design, go ahead, do it. If the result comes back counter to what they thought, what their original research was, they start to look for a problem, right? They start to say, oh, well, actually, that wasn't the best design. Oh, you should have done X, Y, Z. And I think we do that because we're trying to protect, that original result. We're trying to protect our research.
Some of that is part of academic culture as well, which is probably one of the strengths of academic culture. So you are placed, whenever you're proposing research for a PhD or an honours or something like that, you are placed in front of a group of your peers and professors who then look at the statistical analysis that you're proposing and the methodology, and you're essentially torn to pieces. But this is then a post-hoc explanation that uses the same strategy to discredit findings when they don't run in accordance with what I've produced.
That's right. And, the thing is, by doing it after the fact, it's important that you emphasize that word post hoc, because when you want to have that type of criticism, when you want to have that rigor discussion, right, about the analysis, about the methodology, it really should be up front, right? It needs to be about what you're going to do, not necessarily what you found. Now, there's nothing wrong with still criticizing results after, somebody's repeated something, because you can do the best design, and if there's something that you're missing, something that's confounding the entire result, that you only really know that until after the fact. But that doesn't mean that it instantly explains it away. It just means that gives you the next experiment, right? That's the next thing that you're going to start testing. So it's basically replicate and extend. But you can't just extend without trying to do that replication first.
Why don't we reproduce studies?
Yeah, that's a good question. So I think some people will say, well, we do replicate studies, we just don't publish those replications. And I think there's some truth to that, although I don't think it's quite to the extent that one would want. So I think part of the reason you don't do it, or it doesn't get surfaced, is because it's not publishable in the current landscape. And it's not publishable basically because no matter what you find, there's a good chance nobody will ever want to publish it, because either you are repeating something that's already been done, and thus nobody wants to publish it because they said, oh, well, look, somebody else has already done it. Or if you found a counter result, you run into this issue that we were just talking about. Oh, you must have done something wrong, right? You need to have a really high bar to try to, quote unquote, disprove an original result, which really, it's not even what the point is, right? The point is to say, I'm trying to get the same result, and if I can't, why can't I?
I would say that the part of the issue is that researchers within psychology, I think, and who might be more aware of it, but certainly within medical science, have done the opposite of what science is supposed to be doing. So they look for confirmation rather than to disprove their own hypotheses.
Oh, you're 100% right. Oh, no, you're completely right. It's completely, and again, I'll speak again in the medical side of things. That's very much what you see in academia, right? Everybody's looking, and they use those words. They use the words, I'm looking to prove something, right? Oh, this fits my model. I'm looking for data that supports my model. So you're piecing it together. You're creating stories. Yeah, that's not really research. That's not science, right? It's a story. And I think the fact that we even use those words in the community, that itself should be a red flag, right? The fact that we're using these words, we're knowingly doing it, and nobody stops and pauses and say, really, should we be doing this? This is not, I get crafting a narrative to communicate results, but if you're grabbing the results that are convenient for you and you're excluding the ones that are not, then you're really just misguiding everybody.
You're listening to Deep Trouble, Dr. Mark Halloran in conversation with Tim Errington from the Centre for Open Science.
I think right now, and again, I'm going to speak largely for the U.S. population, which is, where my background comes from, but I think this is across the board, is postdocs, graduate, the training has essentially become more of a factory, and they've become a labor source, right, to allow technical work to be done. And so you get technically trained on whatever that new technique is or whatever that area of research is. You're getting more on that technical side.
So you can market yourself. You market yourself as a job seeker.
Right. And I think, there is some, it's not to say that there's no theory, it's the theory of science, which is what you're getting at, right? There's a lot of theorizing in terms of how the result fits into the biology, but it doesn't really talk about how they're doing the research to get at that. Right? Like the way that they're crafting that, the way that they're even conducting their experiments, designing them. Nobody gets trained that. And I think we've gotten to this point where we've expanded so much in biomedical research that it's almost lost now. And we need to come back and gain it again. We need to come back and remind ourselves, kind of these fundamental principles of how research is being or supposed to be done, and start training that. Start getting the next generation to have these skills, because if not, we're just going to lose them. And that's actually, it's incredibly important, because otherwise what we get is we get all these flashy, exciting results, but they're lacking all of that rigor. And they're going to probably keep having these points where, I can't get the same result. I can't get the same result. And I think, we kind of have to stop and ask ourselves, why is that? And there's many reasons. And again, we're not even talking about, one of the worst things, which is fraud, which always confuses me. Like, none of this is fraud outright. Like, this is just the way that the enterprise is kind of moved, and it drastically needs to change.
I think that leads into the second part of the reproducibility project, which is the cancer biology studies. Could you tell me what's wrong with the scientific incentive structure at the moment?
There's a lot that's wrong with it. Yeah, I think, one of the big things that is problematic with it is the high reliance on high profile publications. So I've got to get a paper, I've got to get multiple papers, in Science, Nature, Cell, right? Or some top tier journal. High impact factor, that's right. Let's use the word journal impact factor. And because there's such high pressure, because it essentially dictates your career, it dictates the ability to get grants, to get a job, to get tenure. There's so much pressure to publish at those levels. And those journals, those exact same journals, tend to publish very exciting, novel, flashy, positive, clean stories, right? Things that are just, kind of pushing the boundaries of what we know. And that's really good when it's all pans out. But I think what it can do consciously, subconsciously, right? Because there's plenty of conscious behavior that does this. Like you said, there's a spectrum. But I think it leads people to crafting and finding and basically overcommitting, the results that they have. So they know that, I can't have any negative result, so I'm going to only put positive results in there. Why should I repeat something? If I find an exciting result once, it's publishable. Forget checking to see if it's, something that I can get again myself, because otherwise I lose that ability to get a high profile publication. So I think that's one of the big things, is that there's so much pressure to have these lots of positive results in a paper and very clean stories, right? As if it's all tidied up in a bow, even though we know the research is not that tidy, that it essentially brings the worst out of the research process. Instead of sitting there and trying to be more incremental, more rigorous in everything that we're doing, we're almost encouraging researchers to cut corners, to get those very exciting results.
Well, publish or perish.
Publish or perish, exactly. And so I think that's the main driver. And the reason that's the main driver is because everything else sits around it. So grant agencies look at that, right? Institutions look at that for who they're going to hire, who gets tenure. So it essentially perpetuates itself, and it's really hard to break that cycle. And then you have to ask yourself who you're rewarding, because, if somebody's doing slow, and I mean slow not in the sense that it's any like speed, I meant slow in the sense that they're going to make sure that they do a high-powered design. They're going to spend more resources doing less experiments, but they're going to have more confidence in the results of those experiments. That person actually gets left behind sometimes. And I think that's a shame. Or that person finds negative results. They dig through and they were like, I find some exciting positive results, but I don't fully know everything, so I can't get it published in a high venue. And we actually discredit that person, right? Oh, you're not a good scientist because you didn't publish in Science, Cell, or Nature. But really what we're rewarding are people who are able to do that. And it doesn't mean that, there are amazing scientists who publish in Cell, Nature, Science, but I just think that we shouldn't expect every single person to do that.
Well, let's talk about that. So the Reproducibility Project, 50 cancer papers in Nature, Science and Cell. These are some of the highest impact journals in the world. These are career makers for people. So in my time working in labs, most of the conversations in lab meetings were around excitement about a new result. Can we get into Nature? Can we get into Science? People hurriedly working towards that objective. The replication finds only 2 out of 5 papers are reproducible. That's 40%.
Yeah, maybe we could step back even before our project and actually think about what inspired our project, which is there were 2 white papers from the pharmaceutical companies Bayer and Amgen. And this isn't as if they went out setting to do a project on reproducibility. This is what they do in-house before they start investing millions of dollars trying to figure out if they should, continue research and development on a new drug. They try to basically say, can we get a similar result? Can we extend it to the population that we're going to target? And they saw very low rates. Both of them, 25% was the high mark in terms of what they were able to replicate. But the catch there was that there was nothing to look at. It was a statement. It was a number. But nobody was able to see those results, know what papers that they were talking about. You could guess, but you didn't really know what they were doing. And so that's actually what inspired us to do this project, was to say, well, let's have an open discussion about this, whether we want to or not. Let's be scientists and look ourselves in the mirror and say, what are we doing right and what are we not doing right? And you're absolutely right. Let's grab the most impactful papers. And you're right. The ones that we grabbed, we did citations and like readership, altmetric scores, and most of them are Cell, Nature, and Science papers, which doesn't surprise anybody. But I think we might as well go after those because they're the ones that are creating the most attention. So let's you would hope that those are the ones that actually are going to be the most reproducible because they're being read and cited so much. And I doubt they're being done that because they're not exciting.
Held to the highest standard as well.
Yeah. And when we published our first results last year and even, just published a couple more last week, the big thing that everybody does want to do, and the same thing in psychology, is to say, oh, did it replicate or did it not? And something that I've learned very quickly with this project and continue to learn is that's not very easy to define because sometimes it's very obvious, oh, look, they found something, we see nothing. But it all occurs for various reasons. And a lot of it, I think, is that is basically a lack of appreciation of biological variability, that nobody's really taking that into account. People are very excited about, oh, I found an exciting result, and I'm quick to publish. But I think what this project's already showing is that we, really need to make sure that wasn't just some fluke from a biological what if, right? Oh, the cells just happened to behave differently that day. And actually having somebody else do it again is a good example of, how we can increase the rigor of that design. And the same thing is true. Like we may not get the same result because, well, the cells did not behave the same. And so then we have to ask ourselves, why is that happening, right? Which one, do we quote unquote believe? Which one do we follow up on? But I think what we get more around is, that there's a lot to be learned by going back and being very meticulous in how we obtain the result, not just the result we had. So there's all this attention on, like you were just saying, oh, I found an exciting positive result. That's my ticket to the big Nature paper, the big Cell, the big Science paper. And what we should be constantly asking ourselves is, how did I obtain that? And how confident am I that methodology is not leading me the wrong way?
Am I looking for evidence that disconfirms it?
Yeah, exactly. And I think that's the catch, is that when we find, this project's a good example of it, when we publish a result that is in agreement with what was, the original result, peer reviewers, rarely hear anybody, kind of raise a hand or anything. Everybody's like, oh, yep, that looks good. Yet there were multiple differences between the two still, because you can never do the same thing twice. But with the instant we get a different result, then everybody's looking to find out what the replication did wrong. And I find that fascinating, right? It just illustrates there's this obsession with the outcome, not the way that we got there. So the same way we're trying to sit there and say, oh, I wonder why you did not get a positive result, we should be doing that. It's the exact same reason why we say, I wonder why I got a positive result. Like, is that something that I really am 100% confident in? Or is there something else that could explain it? Or is it was a fluke, right? It's a one-off, like something was different that day in the lab, or the cells behave differently, or the mice behave differently. So I think that gets to the point of how replication helps us as a research community.
You're listening to Deep Trouble, Dr. Mark Halloran in conversation with Tim Errington from the Centre for Open Science.
You've got to keep in mind as well that we're not talking about abstract things. So this is work in cancer biology. So every person who applies for a grant, and most papers end with the tired line that this may one day lead to a therapeutic that's effective. Is that true?
That those papers all end with that line? Almost all of them, yeah. That's the thing about the generalizability and going. At some point, you start to realize that if it is something that can only occur in the tiniest of settings, then what value does it have in terms of being a therapeutic? One of the responses, I forget where it was, I can try to find it, that was when we were, had all the press around those first 5 publications, that I thought was kind of interesting, because it was the same point, and this person I think missed it a little bit, but they were saying how they are consultants for, biotech and pharma companies, and they basically say, whenever I talk to a client, they've got some line of research, and they're, contracting it out at, say, some contract research organization. I tell them never to move in the middle of the experiment. You always stay there and you finish everything at one CRO, because if you move to the other one, it never replicates. You have to stay in one spot, and then that's how you get all the results and that's how you move your product forward. Because if you sit there and you try to have somebody else pick up the pieces, something's not right. And so it's exactly what you're saying, which is like, oh my gosh, like, if you can't pick it up and move it to another location, how are you ever going to how is this ever going to help anybody in the human population, which is incredibly diverse, right? So if we're not embracing that earlier on in the research process, we're setting ourselves up to fail. And if you actually look at clinical trial, success rates, we fail a lot in the clinical trials, especially phase 2. And you have to start to ask yourself, like, how much of it is because we're not translating, right? Which there's always going to be some, right? These are models. We're testing in animals. We're testing in cell lines. We're not testing in humans. But I do think there's a lot that probably fails because of what we're talking about, which is nobody's putting that rigor earlier on in the process to actually say, oh, is this just something that occurs in one location under one setting and can't, extend beyond it? Because if it can't, then it stands no chance. It'll never, ever work in a human population. We should stop it.
My experience was that to succeed in biological science, these are highly intelligent people doing extremely technical work. There's no mistake about that. Where it doesn't seem to work is the statistical analysis between two groups, whether there's a difference between two groups, whether they're cells or they're mice. And to me, it seemed that there was, we've touched on this earlier, there's a statistical illiteracy that runs through medical science, which seems a harsh term, but that was my experience of it.
Yeah, no, I completely agree with you. And the whole thing, because you're completely right that there's a lot of important, like, even when you were beginning apart, a lot of technical importance that has to go into any of these experiments. But I think you're spot on. Part of it could be that, think of the examples that you were just giving, right? There are a lot of big effects, very, like, they are, it's either there or it's not, right? There's these, on off kind of criteria. And I think because there are such big things that have occurred in the past and still do occur, I think it starts to seem as if statistical analysis is just, I think many researchers think it's in the way. Like, oh, either there is a result or there isn't a result, and I can see it. And of course, then that gets around data presentation and all the other things that tie into statistical analysis and inferences, which is, oh, well, you can't massage your data, you can't throw things out if it's inconvenient for you. But I think there is this thought like, oh, it's going to be big when I see it. And I think there's something true to that, right? Which is statistical significance does not equal biological significance. Those two are separate. Just like same thing with, the exact same thing exists in the clinic, right? Clinical significance is different than statistical significance. Stats is a tool. But if you use it incorrectly, it leads you the wrong way. And I think you're spot on that. I think I got no education in it. That's for one thing. I think there's just no education around it. There's not little awareness of the importance of it. I think that's starting to change. And I think that how it ties back into the way you even design your experiments, the randomness that has to occur, right? So I could have the best statistically designed experiment, but if I'm not randomizing properly, that confounds the entire thing. So I think all these methodological and statistical issues are really kind of getting around the way that we conduct our research, and they all, could definitely use some improvement.
Because your background is biology.
My background is biology, yeah.
What was your statistical education when you were doing your biology degree?
My graduate degree, yeah. So in my graduate degree, which was partly at Berkeley, partly at Virginia, there was no formal statistical training that was required of me. Right, so right there, the fact that was the borderline. That's how things start, and that most labs would go to a biostatistician after they did their experiment, right? Which is a good way to perform an autopsy, but not a good way to help design an experiment. And so a lot of mine was reaching and seeking out information. And I think that's probably true for most, at least in the US, right? Most biomedical researchers, unless your field requires it, most seek it out themselves. And I think that's not really the way that it should be done, right? If you're using it, you should know exactly how to use it. Otherwise there's nice plug and play applications that you can use, but if you're not aware of, the implications of it, and you're just digging around looking for P less than 0.05 because, that gets you a nice paper, that doesn't really do you any good. At that point, you should just not even do the statistics, in my opinion.
I mean, it's certainly, there seems to be a lack. And I know this is something that the Centre for Open Science is trying to address in terms of trying to increase statistical literacy, particularly within biological sciences. But I worked with people who were top geneticists, top people in their field, who would have done 2 weeks in a stats course to shore them up before they were running experiments in their PhDs and their postdocs. I gave one researcher a head postdoc a book from Psychology on Statistics, and she just said, I don't understand any of it. So there's a fundamental problem with this to me, because this has real world implications. I mean, this is not as though it's just a waste of money as well. The issue for this was that a lot of these drugs went into clinical application with patients and had no effect, but some of the drugs actually had harmful effects on people and had to be discontinued. This has real world effects.
Yeah, no, you're completely right. I think even in the cases where there's not harm caused, the fact that we have patients taking drugs that somebody could have gone back and, basically done it the way that you were just describing, and it never would have gotten that far, at least at that stage, unless, there was some modification that would increase its efficacy. You're actually giving that patient hope as well. And you're taking them away from something else that could maybe be more advantage. Even if it's not harmful, it could be better for them. And I think that's a lot of harm that's caused in this entire process. There's a lot of people who are starting to write about this exact issue. And I think something that comes up that kind of, again, it gets back at the incentives, it gets back at the way that we as scientists communicate, conduct things, is I think there's a lot of people at these decisions of when to move to first in human, where because it's published in a peer-reviewed journal, it's considered rigorous, right? That by definition, right, because I've published it in a peer-reviewed journal, that means it's passed the sniff test and it's well done. But I think you're spot on. That's not how it works. That is not the best way to go about and decide what to move forward with and what not to, especially when, it's only done on a couple animals. Like we've had a couple replications where the original results were on like 3 or 4 animals, right? And you're just like, oh my gosh, like this is going to be interesting to see what happens when we crank the number up and see if we can find a similar effect. And I think, just because it's published in a peer-reviewed journal does not mean it's quote unquote true, right? Published does not equal true, but we have this mentality and that's researchers and anybody who's a consumer of it, that, oh, that must mean it's true. And that means I can move forward. And I think that's just, it's kind of a waste of resources. And again, it's amazing to say that because you think of everything that we do, how successful we are. Again, if you focus very much in biomedicine, right? Like we have made massive advances, continue to make massive advances. And that's not what we're talking about, right? We're saying at the rate at which we make those advances, yet we're still allowing all of this to happen, we could definitely be a lot more efficient in our resources and what we can accomplish if we spend more earlier on in better designs, and putting more resources in those questions than pushing them, try to get them into the clinic as fast as possible just to continue to fail and waste more resources and hope and potential harm. Yeah, you're absolutely right. There's, very immediate consequences to everything that goes on here.
You're listening to Deep Trouble. Dr. Mark Halloran in conversation with Tim Errington from the Centre for Open Science.
Yeah, I mean, it's not a critique of science itself. The scientific method is the best method that we have to understand the world. But it certainly is, as you said, that if we've made so many advances so far, if we were more rigorous. The other issue that I think is that when you've got an incentivized system where, I mean, part of the reason that people are developing therapeutics and rushing them through into clinical trials is that will attract the grant money. So part of the issue is from the community. So you have not-for-profit organisations set up around cancer or motor neurone or Alzheimer's disease, and they really only want to give money to the researcher who at least pays lip service to the fact that they're going to produce a therapeutic. At the very least, some of these diseases, particularly with devastating neurodegenerative diseases, there really needs to be a focus in funding that really basic science to really get the understanding, and also funding science that is really exploratory, because I think what the funding structure actually does is, for a lot of labs and lab-eds, it makes them play it really safe. So they don't want to take a risk on going down a new pathway, because if they have a year of no results, well, that might be the end of their career.
Yeah, no, you're absolutely right. Yeah, I'm glad to hear you bring that basic understanding. Maybe a year and a half, 2 years ago, I'm blanking on who it was as a MD from UCSF. They had a great op-ed in the Washington Post here making that exact same argument when they were talking about, the dismal rate of phase 2 trials. And basically, their thing is we need to stop pushing it. We need to spend and we need to properly, set up the system so that basic research into the biological understanding of what's occurring, that we reward that we look for more researchers who are doing that. And I think you're absolutely right, which is the system has to be set up to say, what research is that its intent is we're looking for what potentially is there. Doing incredibly basic research, incredibly exploratory research. You don't need to have some exciting positive result. Like, we want to basically know what is potentially a result. But then when it comes time to get closer and closer to the pipeline, we have to start really increasing it and say, well, now we're going to start laying our cards down up front, right? What do we think is actually going to happen here? Because if we're not on the right path, and it doesn't have the application to be able to move into the clinic, and if we're not set up at the preclinical stage to do that, then, we're wasting it. We're kind of spinning our wheels a little bit.
So it seems as though you can go out and you can be rigorous, but the culture really doesn't want to take it on or hear it because it's too hard. I understand it's expensive.
Yeah. No, you're completely right. I mean, one of the things that we're doing in the Cancer Biology Project was trying to align the incentive system a little bit, but basically to still reward that researcher is having a different publication outlet. So we use this in the Cancer Biology Project with eLife called registered reports. And so this is exactly, in some ways, I love it because it solves a lot of these issues. So it says, for any given experimental question and design, I get that peer reviewed before I conduct the research. And again, it has to get accepted at that stage, and it'll get through revisions just like the typical publication process. But once that's accepted, then the results, no matter what they are guaranteed in principle acceptance.
Where do we go to from here? I mean, if we're in a reproducibility crisis, what can the Centre for Open Science do, and what can we do to change the culture?
In terms of what anyone can do is, I think, no matter who it is at any level in their career, the more that you can expose all your results, I think that's going to help a lot. And I think people can start doing that today. There's no reason not to. With everything that's online and available, including what we develop and all these other resources, start exposing more and more of what you've done, and including what doesn't work. So, if you've tried 10 antibodies and you found one that was sufficient based on the, criteria that you've defined, expose the rest so that way somebody else doesn't waste their resources trying to dig around for antibodies. So I think that helps in terms of the efficiency and how somebody kind of arose at why they got the result they did, right? The path that they took. I think education is probably the biggest thing that we can do. The training of graduate students, even postdocs, right? Early career researchers really needs to have more and more emphasis on this rigor in terms of design and statistics. And like you said, we've been working with organizations on this, offering free statistical and methodological consulting ourselves to basically try to help with that. And again, it's all about doing it at the beginning of the design, not at the end, because it's about how you improve your experiment. What is the sample size you need? What is, the considerations that you should take into account before you conduct that research? I think that's the catch, right? The scientific process is essentially the best tool we have, and it's a great tool. But the problem is that it's humans who are using it, and we have a lot of biases that we have to hold ourselves against because we're very easy to fool. And so we can't fool ourselves. And so by stating what you're going to do up front before you do it, you're trying to stop yourself from fooling yourself. And then aligning that with journals and the incentive system, I think, is a way to really kind of move everything forward. Right? How do we actually allow it so that when a researcher does all of these practices, does the properly designed experiment, how do we ensure that researcher still gets rewarded, right? How do they still get the publication? How do they still get the grant? How do they still get the career? Because that's the research that we want to incentivize, and that's the type of researcher that we want. And so this is going to take a long time because we're actually talking about culture change, right? We're actually talking about how do you change the current scientific culture into a culture that is essentially rewarding of this type of behavior.
I think it's admirable but extremely difficult. Just from my observations, I saw PhD students who'd done undergraduate degrees and who were highly talented and who were rigorous and happened to land in a project that produced no results over the course of their PhD. I think that we have a problem in terms of we kind of need a journal of the null hypothesis where people can publish no results so that other people don't, as you said, endlessly try to replicate things that don't work. But then I also saw other researchers who had left when people had tried to reproduce the results, they were reproducible. And so there was a distinct possibility there that people were committing open fraud just to get through a PhD. And it would lead on to a career. There was no incentive to not.
Right. Well, that's a good example. And that's a great example of the scientific method is great, but the problem is we're humans. We've got biases. And if we're not protecting ourselves, if we're not blinding, not randomizing, not holding as much as we can at bay, even the best intentioned researchers are still going to have this problem. That's actually what Glenn Begley, he's in Australia again now. That was the big thing that he did at Amgen when they went and tried to have the original researchers try to replicate their experiments. So this was the pharmaceutical company report back in 2011. And that was the main thing that he had them do was, you guys can do your experiments again, but we're going to blind you. We're not going to tell you which tube contains the drug, right? There's so many opportunities, but especially when there's any subjectivity to it, even when there's not, knowing what you hope to find is really systemic, and it's a problem that needs to get shifted, and it gets back to training essentially and awareness.
I mean, you can kind of see it from the perspective of a post-PhD student looking to get a postdoc, gone through an undergraduate degree. There's massive amounts of competition for jobs. The job market is incredibly unstable, so people are living on 6 or 12-month contracts. They're in their PhD, they're set a project looking to find some sort of therapeutic effect for a drug that's been developed in the lab, and all eyes are on them to get some sort of result. That could be their career. Them getting a null result could be the difference between, and a positive result is the difference between them getting a postdoc and not getting a postdoc. That's a massive amount of pressure.
Oh yeah, no, absolutely.
And so they may be well intended, but it simply encourages the shortcut. It encourages not looking. It encourages all sorts of things that are counterproductive.
Yeah, with our project, just as a heads up on that, like we're hopeful by the end of this year, maybe beginning next year, to have it published, because we're trying to wrap up everything right now. So I'm sure we'll make some more waves again when that happens. I'm sure we'll have some upset people too.
Well, one of the points that was made to me by a scientist was they said this project is funded by John Arnold, who's a venture capitalist, and so is this in some way biased or something like that, or it's in his best interest if he wants to invest in pharmaceutical companies to discredit drugs coming out of one area and not another. So I don't know whether you'd comment on that.
Yeah, I'll give you a quick comment on that. So one is, there's no influence from our funder on which studies we did, because they weren't handpicked. They were picked through a process that's exposed. People can see it. And when we publish all of this, it's independent from them. So we definitely don't have any influence from our funder in terms of the direction of the project. Every single paper we publish, it's in there that we have that. But then nonetheless, they're publishing us. So there's a good reason to do that. I'll give you the reason why they funded the center and probably why they funded this project is when the Arnold Foundation, when John and Laura started to give away their money, which was not relatively that long ago, they wanted to figure out where to invest their money. And they were very focused in nutrition research. And they basically couldn't quite, basically from John's background, right, basically trying to, being an incredibly smart person and wanting to hedge his bets on where, because you can't fund everything. So who am I going to fund? Who am I going to invest in? And they basically realized as they dug farther and farther into it that there was a problem. Right, that there was a fundamental problem in the way the research was being done, and that there are essentially groups that are propped up, all built on questionable results at best. And that led them into essentially investing in organizations like us, like Metrics at Stanford, to basically say, well, geez, what can we trust? We have to investigate, we have to change the way that research is done, because clearly, just because somebody published one study doesn't mean that that's what we should all believe. And so that's the reason why they even funded this project, was to sit there and actually not to point and look and say, oh, I want to discredit a certain area of research that I'm going to invest in. It's more about saying, how do we even know anything that's coming out of science unless we're really rigorous about the way that we're doing it? And we can only do that if we evaluate it, if we actually study it and try to change it. And so that's about the best I can say from it, because I actually find that makes perfect sense, right? If I had which I don't, if I had that much money and I was giving it away, I'd want to be sure that I'm not just giving it because it sounds good. I'm giving it because it's based on sound science.
So it's potentially I don't know how often that happens, it's potentially a paradigm shift instigated by someone outside of science who had no vested interest in it, well, apart from their own vested interest of wanting to do well financially.
Right. Well, and part of basically saying if I'm going to give my money away and I'm going to try to make a difference, I better make sure that it's making a difference. And I think that's basically what it's built on. And that's probably the most fascinating thing is that it's not just, the Laura and John Arnold Foundation. There's other private foundations who, basically that's the only place. Gates Foundation does a little bit of replication research and impact evaluations. And I find it fascinating that none of the government foundations, publicly funded foundations, have kind of entered it outside of the Netherlands, like a health organization that just recently is doing a test of this. I just find that kind of fascinating. And it gets back to how do you change the machine, right? Like, how do you change if all researchers are getting incentivized to do new experiments, do novel results? Nobody's ever asked to try to replicate something. That's, the funders aren't encouraging it either.
Well, I'm hoping it changes with one public conversation at a time.
Yeah. No, and I think you're right. I think and sadly, it's going to probably be slow, but I think the more people that can continue to have conversations about this and raise issues, I think it's only going to lead to the better outcome in the long run. It's going to take a while to get there.
Well, anything worth doing is worth doing well, apparently. Thanks very much. I hope you have a good day.
Thanks. Well, good day for you.
So, Mark, I found that fascinating. That was great. One public conversation at a time, hey? Was that just one of the public conversations that we can start this with? Because it's not a subject that's often covered, is it? People accept the results of experiments. They don't think about the need to reproduce them.
It doesn't come up in the public conversation. I mean, I found the Centre for Open Science and Tim Errington through Facebook. I think Mark Zuckerberg might have shared an article about the centre. I think it's important to note that the Gates Foundation is also embarking on replication and reproducibility. That tells you everything about the state of play, that government organisations are being left behind. These are the leaders. You don't hear these conversations on the ABC, you don't hear them on Science Friction. It's very hard to cover these sorts of topics because it takes very, very specific knowledge.
Indeed. And there's huge forces behind these things too, isn't there? There's obviously huge forces behind these organisations that are going for checking reproducibility, but there's huge forces behind science itself and having to publish.
It's a cultural problem in terms of the way that we value science. I mean, part of the problem is the environment that scientists have to operate under. I talked to Jennifer Byrne about the reduction of funding from government bodies from 30% to 9%. The pressure to produce positive results is incredible. And also from philanthropic organisations, well-meaning organisations, so organisations that are set up to raise money from the public for cancer, for neurodegenerative disease, Alzheimer's, motor neuron disease. The reason I went into my PhD, my background was psychology and I went into biochemistry, was because I had a relative who died of motor neuron disease. And there are people who are incredibly dedicated, incredibly talented, incredibly intelligent, working in these fields on these problems that are incredibly complicated, intractable.
Yeah.
But the culture, the pressure of the culture, the lack of funding and the lack of reproducibility is creating a problem which has real-world effects. I talk about drugs that make it into phase 2 trials, let alone drugs that do nothing, but drugs that actually have harmful effects, which is, when you look through the literature, you can find that. We can do better than this. Science is already providing us with lots of really, really important solutions to this. And the point of this is not that science doesn't do that. It's that if we funded science better, if we valued and respected scientists more, could we actually see cures for these diseases in maybe 20 or 30 years' time? That does not seem possible necessarily in the current environment.
Tantalisingly close, though, you would think. I mean, 30 years isn't long in science, is it?
30 years is not long in science unless the paradigms
remain as they are.
As they are. Like, you hear about the successful trials, but you don't see the innumerable phase 2 clinical trials that fail. And the point of this is that they probably didn't need to get to phase 2 trials into humans, because if the studies had have been done more rigorously at the preclinical stage, then it wouldn't need to get to that point. We need to focus, particularly with some of these really devastating diseases, on some really basic molecular biology and really get the understanding there, rather than aiming for this therapeutic. The therapeutic would be good, but scientists are pitching this to these organisations and the government to try and attain funding. And also playing it safe as well to some extent, because you can't afford to take a risk on a really innovative project necessarily, particularly early on in your career or a mid-career scientist, because if you don't get the results and the papers with the impact factor, then you're gone.
Your career's over.
Career's over.
Well, look, an incredibly important conversation, Mark. I want to commend you once again for doing it. And I want to thank Tim Errington for being with us in Deep Trouble. Now, should we just briefly cover who we're going to do next week?
Next week we're talking to Professor Bain Atwood, who's a historian at Monash University. And his interest, his field of research, is the history and the culture of the Dja Dja Wurrung people, as well as the history of colonisation in the local area, so the goldfields area, and the protectorate system, which was overseen by the Chief Protector, George A. Robinson, and the Protector for our region, as we well know, was Edward Stone Parker.
Yes, we certainly do. So brilliant. We'll call that part 2 of our series on Dja Dja Wurrung after Uncle Rick Nelson.
Some sequels are equals.
Brilliant. I like that. All right. Thank you again, Mark. Look forward. Thank you for being with us on Deep Trouble for another episode. Tune in next time. It's going to be awesome.
Deep Trouble is produced by Steve Charman in the studios of Main FM, Castlemaine.